In the heart of the galactic core of the Milky Way there is an unfathomable destructive power of nature. Sagittarius A is a bright and very compact astronomical radio source. Observations of a number of stars orbiting around Sagittarius are like the star S to have led some scientists to conclude that Sagittarius A is beyond any reasonable doubt the site of a supermassive black hole. Conclusive evidence that Sagittarius A is a black hole was announced in a paper published on October 31, 2018. Using the gravity interferometer and the 4 telescopes of VLT, short for Very Large Telescope, astronomers created a virtual telescope of 130 meters in diameter and used it to detect gas clumps around Sagittarius A moving at about 30% of the speed of light. Astronomers also reported that S2 was orbiting Sagittarius A at an utmost 7,650 kilometers a second, or about 2.6%. the speed of light, at about 120 astronomical units from the black hole. Einstein's theory of general relativity predicts that S2 would show a discernible gravitational redshift in addition to the usual velocity redshift. Astronomers confirmed the gravitational redshift was detected. In agreement with the general relativity's prediction, in our previous video we explained the mass of stellar black holes is greater than 20 solar masses. Sagittarius A has a stunning mass of 4 million times the mass of the Sun. On February 11, 2016, the Laser Interferometer Gravitational Wave Observatory LIGO announced the first direct detection of gravitational waves, which also represented the first observation of merging black holes. The first ever direct image of a black hole was published on April 10, 2019, following observations made by the Event Horizon telescope of the supermassive black hole in the Messier 87 Galactic Center. Observational evidence indicates that nearly all large galaxies contain a supermassive black hole in their center. An almost unbelievable fact about supermassive black holes is that their average density can be less than the density of water. This is because the sparse child radius of a supermassive black hole is directly proportional to its mass. In addition, the tidal forces in the vicinity of the event horizon are significantly weaker for supermassive black holes. A person on the surface of the Earth and one at the event horizon of a 10 million solar mass black hole experience about the same tidal force between their head and feet. But make no mistake, once you go deep into the black hole, the tidal force between your head and feet becomes greater than the molecular forces holding you together. You will undergo a process known as spaghettification. There is another breed of black holes that make supermassive ones look tiny in comparison. When astronomers discovered TON 618 to create a whole new label for these types of colossal objects, ultramassive black holes. TON 618 ab airy, distant, and extremely luminous quasar, and it contains one of the most massive known black holes with a whopping 66 billion solar masses. As a quasar, TON 618 is believed to be an accretion disk of intensely hot gas swirling around a giant black hole in the galaxy's center. The surrounding galaxy is not visible from Earth because the quasar itself outshines it. It shines with the luminosity equivalent of 140 trillion suns, making it one of the brightest objects in the known universe. Thanks for watching. Did you like this video? Then show your support by liking, subscribing, and ringing the bell to never miss videos like this.